Okay, so I'm Liz. I work for the ARC. Yay! So some of you were here last time. Last time we went through things for the exam in the Steel Manual, and then also some of the important pages that you might not know are in there, but they're in there. So I'm just gonna, for the beginning, while you're kind of formulating questions in your head, go through the important pages in the Steel Manual. So, very first important thing, at the back of the Steel Manual, there is a general nomenclature page. It's on, for those following along on the internet, after page 17-44, the numbering starts all over again at general nomenclature. And then after that, there's an index. So if you can't ever find anything in your Steel Manual, there is indeed an index in there that can help you find what page you need.
What page is it?
It's at the very, very back of the Steel Manual. It starts numbering again. And then also towards the back of the Steel Manual, it's basically all of chapter 17 in the Steel Manual, which is at the back. It's got a little tab already there for you, just labeled MISC. It's miscellaneous data and mathematical information, which gives you SI equivalents of different kinds of shapes. And then at 17-34, there's properties of parabolas and then geometry formulas. So if you have weirdly shaped things, it'll tell you how to get the area of things or how to find I of different strange shapes. Like it's got all these like squares and rectangles and then a formula for I, which is great when he gives you strange composites. You have to find things like Y bar or I. It's got formulas for that. Oh, for Michelle who just joined us, right now we're going over all the extra things at the back of the Steel Manual. So chapter 17. People can still hear me on the internet. And also important things. There you are. Okay, and then last but not least, for the really important things that you can find in here is 3-213 in the Steel Manual is basic shear and moment diagrams.
What page is it?
3-213. It's right before you get to the columns tab. So in here you've got like shear moment diagrams, and it's got how to solve for like moments and deflections and stuff like that for that. This is a lot more important, I would say, for like structural analysis, and then it's going to be really super important next semester, but for this class, I mean, who knows what he's going to throw at you on an exam, so this could be super nice and very handy, so that way you don't have to go through and figure out how to do this yourself. You can just kind of wing it from the tables. Okay, so then, does everyone still have, hello people on the internet, I see you raising your hand. Do you need help? Do you need assistance? This is my first time using the weird Blackboard system, so I'm kind of like, I don't know. Yeah. So does everyone still have like their tabs in from the last exam? Does anyone need any help with how to find things that were used on the last exam in the manual? Is everyone good with that stuff? I get blank looks, so I'm assuming we're good. Cool. So for this exam, did he give you specific direction on what's going to be on it? Like, I know... What?
Only compression members.
Yeah, but he said in the email that we gotta know the parallel axis theorem. I don't know why.
And also
And then when I looked at some of the example problems, he didn't go over them in class, but there's like you have to do this moment diagram, or not moment, like you have to find the charts again, which I'm kind of confused about, but looks like we had homework problems on this, but I just check.
We didn't have any homework problems.
Yeah, we did. 4.9. So, yeah.
Hello?
I don't know.
he also said there were 7 coding questions. Do you know what that means?
I don't know.
On the city court building.
So he said there would be a tiny little question on the article.
Oh, I
I
see.
don't need to be connected about.
So, for those following along at home, parallel axis theorem is going to be on the exam, and it's supposedly only going to be compression members. But I would be sure you know everything you can possibly know about those compression members. So, for that, you've done stiffened and unstiffened, I'm assuming, and composites, or also slender, non-slender. Are all the things I'm saying sounded familiar? Okay. So, for all of that, did you sticky these things in class at all? In the back, where they've got like all the tables and charts? Okay.
Do you think it is good choice for me to go to
For members with slender elements, the best thing ever is 16.1-40. They have all the instructions on when to use these formulas and which formulas to use these with. And as I was talking with you earlier before we started this up, when you're looking at things, be sure to pay attention to if something is stiffened or unstiffened. Like he'll say this part is stiffened, or this part is braced, or this part is resting against something else. So pay attention to that. And then you go through the process with the stiffened and the unstiffened with the different members. He'll say for like the flange is stiffened and the web is unstiffened, and vice versa. That's the biggest is the thing that you take through. So you'll go and you'll calculate out for like the flange being unstiffened and the web being stiffened. People. You'll go through that, and then the thing that turns out to be the weakest member is the one that you will then design for. When you're doing design problems where you have to choose a member, if the member that you choose is slender, you have to that it's okay. So if you go to the very beginning with the design tables for different members, let's see if any of these. Where's it good? Aha, good example. They have the design members, if they have a little C right next to them, then they're slender. The good thing on exams is there's typically multiple right answers. I would just go for the one, unless it's like super obvious he wants you to do a slender member, go for one of the ones without a little C next to it. Because typically for those, you can bring them through and then you're good, and then you have a member that actually works. But if he's like really trying to, like, and then prove that, the slender member can indeed succeed this, then, you're stuck. And that's what you're going to have to do. But you can save yourself time on the exams, which is important. So these guys will indicate whether or not they're slender here. And then the same thing is true in the other tables. So I believe you're going to be using the Z tables, Z selection tables. Or no, because these are all tension, so never mind. Probably not going to be using those.
The available strength table.
Yeah, available strength tables is what you're going to be using for this one. These will typically also indicate if they're slender. Nope, never mind. It's not these tables that indicate if they're slender. For these, you'll have to go back and you'll have to look it up in the other tables if you just want to spot know if that's a slender member or not. So, does anyone have any specific questions for me? Anything about how the process or?
Here, I'll open the email.
Can we go over a parallel axis theory problem?
Do you have a problem for me? Because if I can solve it. I didn't prepare any
Let's just do
problems to do.
Hold on, let me see what he wrote in the email.
And do you have any idea what probing questions mean?
With
Yeah.
what means?
Probing questions?
Probing questions?
Yeah, he said,
Yeah.
yeah.
Neither do we.
Because I was assuming those were about the article.
Yeah, I don't know what they are. What does that mean?
Questions?
It's 7 probing questions.
I mean, there's going to be 7 of them, so.
Yeah, actually, there's actually 3 problems and 7 probing questions. Oh, wait a minute, maybe it's probing if it's inelastic or elastic ring? Or if it's slender or not.
Oh, torsion.
Or they could be the ones where it's like stuff with W-shaped that's blah blah blah.
I don't
I
know.
probably went through all those.
I don't really consider that.
And then he says review becomes. And then he said.
Oh, okay. Oh, okay.
He said, please note as you're reviewing things, become expert with the parallel axis theorem and computing area properties.
So with that, the thing to do when it comes to parallel axis theorem, area properties, that sort of thing, that's how do I calculate I and Y and X bar? That's
Yeah.
really,
Yeah, I'm kind of confused on that one.
okay. So calculating Y,
I have an example here.
Y bar and X bar, that's all what is the area of this point, and then measure to the middle of that point. Then you sum up all of those, and then you divide by the total area. So, if you get,
He gave me an example.
oh, you did?
Yeah. Look, here's an example here.
If you email it over to me, then I can pull it up on the screen too.
Oh. Yeah, I can do that. That's not a problem.
Emailing better PDF.
No, I'm not. No, I have screenshots. I forgot which one was which. Oh, it's this one. Hold up. So yeah, just give me like a second.
I show up. Oh, yeah, I was gonna find torsional things.
He did one in class, so.
I have a sticky note for them. Oh, T-buckling. Have you all done T-buckling? Or is that too soon? Nope, too soon. Just kidding. Carry on. Watching. Reflection.
It's a question of flexural torsion.
I don't
So with this, going back to about how you would do things with parallel axis theorem,
I'm saying it right now.
I bar, or sorry, Y bar and I.
What's your email?
E Mullen, MULLIN. Yeah. It's all about chopping things up into pieces. So like if you have something like this, you can make 3 different areas out of that. Doesn't quite draw you take the middle of each of those areas and you will measure out to that middle. And then if this is y bar, you're going to do area times distance, area to distance 2, and it'll continue on over the sum of the areas. So that's super simple. And then with I, when you're adding up all of your i's, it's just important to make sure that you include all of the i's that you're given. So you want to add the I that you look up in the book that's specific to your member. And then I believe it's area times distance squared. Does this one sound familiar?
Yeah, that's
Sorry.
80 squared.
Yeah.
I bar plus 80 squared.
And then if you have a composite, so two different shapes combined with each other, then you need to do the for both of them. So you'll have, for I bar, you'll have like a distance ratio for both of them.
Yeah. The question is, which one's D again? Yeah, or I sent you an example problem, so.
Well, let's have
Nope, not to my email yet. Ah, now it's here.
It's like the bottom one.
Okay, let's see if I can share my screen.
I have a hard copy right here.
I can't seem to share my screen with them.
It's like example.
Example 4.17.
Yeah.
I don't watch this exact problem again. I'm an expert in this. Oh, I figured it out for everybody. And Wes, by the way, that example was the answer.
Oh, man. Oh, I haven't even started looking at it yet. What's your email, George?
I'll take the book club after we go get it tonight.
So, let's go back to this guy.
Downtown.
So,
Not 21 yet.
What's your email?
No, I heard
where
it.
is this guy? Oh, is what I'm drawing on the board not showing up? Okay.
Are you switching?
Alright, there you go.
Are you switching? Do you want this tonight? Or can I send it to you tomorrow?
You can send it tomorrow.
Yeah, because.
Not probably gonna just finish this.
Yeah, no,
Yeah.
I just studied
I'm just gonna put you on.
So if we go to the problem, the example problem that you showed me, we've got an I-beam with a tiny plate on top. I'm sorry that my drawings aren't matching up, but you get the picture. So if you're going to take I of this, you've got to do I bar as it calls it, which is, well, if you look this up, what's it going to be in the manual? And then you add to that AD squared. This D squared is what's known as the perpendicular distance. So, first question you need to ask yourself is, where am I drawing, where am I rotating from?
Plate. In that case, how do you find the I then?
The I of the plate?
Yeah.
So, I have this plate, like the I bar, get close to the mic. The I bar of said plate up there would be, that would be something you can look up at the back of the book, the little formula that's there for how to get I of things. So like properties of geometric sections, how do I do a rectangle? and it'll then give you how to do I-bar. There's like basic formulas for I-bar for all of the different shapes, and you can memorize them, or you can just look it up in the back at the geometric sections.
The geometric sections.
Yeah, properties of geometric sections.
What
So
page?
like on page 17-37
Yeah, I get
of
like,
your steel manual at the very, very, very back.
yeah, it's I equals D to the third of the 12.
Yeah.
37.
So it's, yeah, 36.
Mm-hmm.
What is that, George? So,
36.
uh,
I think it's that.
compared to what you did in class.
Yep.
That's how you figure out I-bar.
Yep. Of that specific shape.
If not I-bar, then like for the plate, or not for the plate, for the whole flange and web, that's that's IX.
Yes.
Okay.
So like the I-bar for the whole flange in the web, as we said here, is the IX you would look up in the steel manual at the very front in the properties of the shapes.
Yeah,
So then-
the areas are also easy because you can just look them up.
It's just D that's hard.
How about Y though? How do you find Y?
Y?
Yeah.
So Y in this case would be D, I think, is what we're talking, because, or is it Y bar that you're talking about?
No, if you go down to the next page, next one,
Oh.
and you'd be like, yeah, next one, on that one, there's a Y and a D at the top.
Okay. So Y here, I'm pretty sure what they're intending Y here to be is the distance to the middle of the object. See here,
Yeah, but if
W9.
it's 18 for W, then how's it 9.575? Does he just add 18?
Thickness of,
Does he add the 3/8 with the 9 or with the 8?
Let's see, this bar we're talking about is 18 by 65. I feel like this is something that you're getting out of the steel manual, because I'm not entirely sure where he's pulling these numbers from.
comfortable thickness.
Yeah,
That's what I was thinking.
with 3/8, right?
Way to do it in class, but it's a lot easier.
No, it's gonna give you 9.18. It is what? It's 3/8 times 4.
Dude, even the book example. Even the book example.
Alright.
Just hope there's not one like it.
Every year.
Yeah, I've not seen him using this value at all, though, in the book.
It's still, the lines will be still.
So it's what, 3/8 divided by 2?
3/8 plus, here, this is essentially good.
Plus 18.
Yep, I don't know where he's getting these numbers from, but he isn't using them for any of the calculations that he's doing. So I'm not entirely sure what he's intending Y to be, because it's obviously not what's the middle of the shape, because that's what you would typically use Y as.
So why? Okay.
Yeah, so Y should be your middle of the shape, though in this book problem, I don't know what's going on, but this is once again like, it may be that they intended Y to be something else in the book, but also a lot of example problems in this book are wrong. They mess up their numbers and can't do math. I don't think this book was well edited when it was published. And then also when you're doing these homework problems, by the way, the solutions for the book also a lot of times are wrong. So like it'll have like the little like, what's the solution of this problem down at the bottom of the problem, and a lot of those are not what they should be. So take this book with a grain of salt. The steps it goes through are all correct. Like, the steps are not the problem. It's the math done for those steps. In this book, typically, that's the problem. I believe there was one example that we found where it listed a type of beam, and they looked up a different beam for the numbers and used those numbers throughout the problem. So, like I said, take this book with a grain of salt.
Yeah, sometimes the K values are off.
But like for D, D is the perpendicular distance to the centroid. So like here with this x in this problem, I'm gonna finish drawing this all out. So here's where this x is where they are trying to take I from.
Oh, we figured out how to do the y.
Okay, so what do they intend for
So
y?
you have to go to, so if it's w, what is it again?
1865.
Yeah, you go in your manual in the beginning, you find your depth, and that's like 18.4.
Okay.
Divide it by 2, and then you add 3/8. So you got to take your depth, divide it by 2 and add 3/8, which is the plate.
Okay. So if you didn't hear that, we figured out how in this book problem they solved for y. They took the depth, they divided it by 2, and they added 3/8.
You find your depth in your steel manual.
Yeah, the depth looked up in the steel manual. I'm not entirely sure why they would add 3/8, because this is a symmetrical shape, and you should just be dividing it by 2. But I don't know what they're doing. Okay. So then, your D, your distance away from this x point. So like, this x bar is going to be the middle as far as distance from like the bottom of this I-beam to the top of this plate. So it's not going to be the exact distance of this I-beam. Where its center would be, which would be probably about right there. So then that's why in this book problem they have such a tiny number for D for the WB, and then a bigger number for this plate because the center of the plate is going to be right in the middle of the plate, right about there. So when you're doing AD squared, you're going to do AD squared for all of your components. So you've got I bar for your component, and then AD squared for your component. And then, since this is a built-up member, for each component, you do add another I bar, and then you add another AD squared for each component. Does that kind of make sense? Because this is like for the middle of the object. And then this AD squared is relating that object to its total like composite glory. So it's all like this is it as an individual and this is it as being part of the group. So you have to have both components there. I'm getting a lot of like stares. Is this making any sense?
Not really.
Not really.
Also, how do you find the distance? That's where
Where's them solving this?
Doesn't help with our learners. Static.
Yeah.
I mean,
Okay. Going back to the whiteboard thing. I want to see if I can draw this better because when I'm drawing with the pens, it's not picking up too close. So I'm trying to draw this with my finger and it isn't going well.
Tell me if they live. Yes, over.
Going at this again.
Hey guys.
No good solution to make this look
I
nice.
was gonna find why.
It's really good at finding where numbers come from.
But see, there's people on the internet and they're watching this, so I have to accommodate for them.
Looks like we just lost connection.
Cool. So then, in the middle of this, so this like, say this entire shape is 10 high, and then like this one right here is like 1, and this one right here is 9. So the middle of this entire shape is going to be x, which is going to be 5. So this is what we're taking our total I from, is from this x. It's in relation to this x. Now each of these shapes on their own, this I-beam is 9 tall. So its middle its own individual middle is going to be 4.5. And then this thing all on its own, its individual middle point is going to be 0.5. Because we're taking this as these are glued together and this is its own shape, we have to accommodate for the fact that these guys, their centroid, their middle, is not the same as the total shape's middle. So when you're going through and calculating out what your total I is going to be, what you have to do is you take the I from like the book in the case of the W, or calculate it from the tables in the case of this plate. You take that I value, but it is with X being 4.5. So you have to add an extra factor onto it, which is that AD squared, in order to realign this 4.5 to the actual middle of this as a composite, which is 5. So in this case, D would be 5, the middle of it as a whole shape, minus 4.5, the middle of it as its own shape. So in this case, D would then be 0.5. So this is like what the I of the shape is on its own, and this is like an adjustment factor to adjust it to being a composite. And then for this guy up here, you would add W. Alright, so bad. Oh well. So you have the I of this is a plate, which you would calculate either from the tables or you know what the mathematical formula is for that object. And then you're going to then add on another adjustment factor. So this one, the middle of this one is 0.5. We have to adjust the middle to being at this 5. So you do 5 minus 0.5 for the D in this case. In this case, D is going to be 4.5. Because that's the distance needed in order to adjust this to being where X is. Does that make more sense?
Yes.
Good. And then these areas is just the area of its cross section. So this is the area of a rectangle, and this you can find in the book.
So the total, the IN or IW is what now?
The IW, this is what you look up in the book for this shape.
Okay.
So under the IX column that's typically the I that you would pick for anything.
X6.
Yeah. People on the internet doing good now? Can they see things? Are things making sense? You can shoot me to keep going in the chat, or you can ask questions. I'm trying to pay attention to you. No one says anything. No one's paying attention other than that. It's okay. But does this make sense? This is like the hardest thing you're going to have to do. We're on my exam for this thing. He gave us some composite thing. Looked super weird. It was like that was on my exam. It was something really strange, and so you couldn't look it up in the book. Because how I had been gliding along to this point is, you look this thing up in the book and you hope to hell that you got this part down here right, and you just kind of go at it. With something like this, whoa, there go my glasses. You can't do that. So with something like this, you can break this up into 4 different rectangles, and then add them all up based on that. Or I believe in the back of the book, there might be an individual thing you can look up to calculate I for just the shape in particular. But if you get something like this on it, your X bar is going to be in the middle. Assume that this is symmetrical and not a terrible drawing like what I drew. You can just break this up into different rectangles and then calculate X from there. Because these two would be super simple because their X's would be in the middle, so you don't have to add this AD squared, because in that case B would be 0. You only have to do AD squared for this one and this one. I doubt he's going to give you the same thing that he gave us on my exam, but if he does, that's how you handle this.
So basically just calculate the ID squared from the bottom to the top.
Yep. You'd have to add an I for these two shapes, but for them, their middle is in the exact same place as x. So if you were going to add ab squared, b would be 0. So that would cancel out that part of the factor. Okay. This all, we good here?
As good as we're gonna get.
What is the D, the first D? That's our
B right here. So this would be D for W. If we assume that the middle for the W is 4.5, and then just X, the middle for it as a composite is 5, you just subtract them, and then you would get D is 0.5.
Basically, that's E, right?
Do you have any other questions about this thing? This was, in my opinion, the hardest thing for this part of it, because everything else you can just sort of look up in the manual, and you can follow the instructions. This part you
So
can't
this
really.
part is just for D. Okay, yeah.
Yeah. Do you understand how to use I?
Yeah.
No, wait, what do you do with that?
What do you do with I? So for I, typically what the end goal is in this case, have you all done deflections or are you not yet to deflections?
Not yet.
Not yet to deflections, okay. So you're just trying to find W, right?
What does that mean?
What's W?
That's what it is.
Okay, let's go with that part.
Yeah, for the frames.
Oh, yeah, it's good. Right. Yeah, with the
Well, no, that's what I'm saying. Like we have to use these, and then it's
We use it to figure out what could access control is.
Yes. But I'm trying to find a good way to go through this. Sorry. So you use it to find R. Okay. So someone had asked previously something about torsion. I don't remember if it was online. Yeah, someone online asked about torsion. Torsion is 16.1-34. It's got all of like how to go through that. So if you're worried about torsion, that's there. So there's Rx and Ry that you have to use when it comes to torsion. Do these values sound familiar? You heard of Rx and Ry? Okay. We're on the right track with that then. So Rx and Ry, those are the radius of gyration. And that is something that you can get from I. But you can also look it up. Where is... So in most cases, you can just look up Rx and Ry. Those just come from the tables for these W beams.
Also,
That's just there.
we found out a way to find out. D.
D. Okay.
So you have to find the Y bar.
Oh, people here found another way to find D. You're going to take the
If you
Y
go back
bar.
to the example problem on the
Mhm.
first one, it shows that you have to find Y bar. First one, or the first one. Yeah, that one.
First page.
Second
Sorry.
one. Yeah. So you see that Y bar over there?
Mm-hmm.
You have to find that, and then you subtract that to Y, and that's your D.
Yep. That would make sense because your Y bar, that is the center of that shape.
It's the center of the shape.
Yeah. The center of the individual shapes is each Y bar. And then the center of the shape as a whole, that's the Y bar. That would be like the X in the example that I drew. But yeah, it's basically just another way of doing that. So if it makes more sense to use things with Y-bar, then totally go for that. Aha. Square root of y over a. There we go. So when you've got Rx and Ry, and you have a complex shape like this, you can just take this I, and then it's the square root of I over a. So it's the area of this as a whole, and then I, this shape as a whole. So when you're trying to do like your KL over R and stuff like that for a composite, then you need your I in order to calculate that.
Should make easier test than the last one.
This one, if you know how to do this, it is a much easier test than the last one. If you don't know how to do this, then it's not.
Looks like we're doing some practice.
Yeah. Starting at in the book, chapter E, which starts on 16.1-31. That's all design of compression members, and it has all of the formulas you will need basically on the test in that chapter E. It's at the end.
Hallelujah.
So, yeah.
It has everything you need for this.
Well, not everything you need for this test, but it has like all the formulas and kind of like step by step, because it starts off with flexural buckling, and then it goes into torsion, and then from there it goes into slender members. So you can follow like the instructions of how to do all the equations. And then it helps if you just like go to your notes and then write yourself little notes along the side of all the equations of all like, here's how I do this part, and this part is the best way for solving for effective lengths. So like, don't be afraid to write in your steel manual and write yourself instructions on how to do these things. Because like here, I circled a U. I thought that was important. Just like, mark this up because you're allowed to take this to the exam with you, but it doesn't help you at all if you can't figure out what's going on from here. Yeah. This is with slender elements, which starts on 16.1-40.
But I thought his exams were like trivial or like simple usually.
His exams?
Like I've had them over the summer, and I had them also for the first exam.
Uh-huh.
They were pretty simple, just these exams. They were not. Most of them came either from the homework or from example problems in class.
Yep. The only thing to watch on his exams is the language, because sometimes he'll change up how he says something. So it's really important that first you try to identify what he's asking you to do. So like, first ask yourself, am I doing a design or an analysis? So for a design, is he asking me to give him a beam recommendation at the end? So then you'll start from the beginning with like, what are the guidelines he gave me, and just kind of go through that. And then the other thing is he asking me to do an analysis where he's giving me a beam at the beginning? And then am I doing something with that? What?
And then those will be a pass or fail kind of thing. Like either yes, it supports it, or no, it doesn't support it.
Yeah.
Okay.
So it's really important that you watch the language, and then like, is something stiffened or unstiffened? Is it braced or unbraced? Like, it's really important to just sort of watch the words that he puts in there, because he sometimes tries to trip you up with what he puts down about the problem. So it's important not to get lost, because on a lot of these, there's just like, it's the exact same process that you go through each and every time. With a lot of the questions on the exam, he's not going to ask you to do the whole process. He's just going to ask you to do like a quarter of the process. So like, he might give you something like this, and then you're used to having something like this and taking it all the way through to see if it will handle the load. He might just ask you what I is for this. He might not ask you to do the entire problem. So it's just important that you stop when he tells you to. know what it is you're trying to achieve with the problem. I found on his exams it's really helpful for me to write out what are all my known variables, and then I can look at my equations and say, what do I have? What can I calculate with this? Because that will a lot of times lead me to where he needs me to go. Do we have any more questions? Are people good? Because also, we have this room until 6. So if you want to, you can even have just like 15 minutes of just kind of colliding with each other and seeing where people have marked things on the book and writing notes for yourselves if you want to. I mean, that's kind of why I started holding these when I went through this class. Me and my friends got together the night before every exam. We would sticky note up our books and go through things together, and I think that helped a great deal. So,
When do you use iteration?
iteration.
You said you would specify.
He would tell us when.
Yeah.
Wait a minute. I thought I thought we could use both.
No, you can't use iteration if you can't find the compression numbers.
Wait, so we gotta use iteration?
You can find the shape, yeah. The shape isn't in there, because the shapes only go for like W. So if he gives you like a W21 by something, see like this.
Yeah.
Any more questions from anyone? No? Cool. I'm going to go on ahead and stop recording then, and then y'all are welcome here until 6. And I'll still be around if you have any. Oh, yeah.
An example that you did in class.
Sure.
I'm just going to show you.
Okay. Thank you everyone who joined us online. We appreciate you. Have a lovely day.